So when we talk about microbial growth, we're just looking at the increase in number of cells and not the actual increase in the size of the microorganisms. So that's really important to remember. So there's a couple of requirements for microorganisms to grow and increase the number of cells. So we've got physical requirements. We'll look at temperature, pH, and osmotic pressure. And there's also some chemical requirements. So we'll look at some various chemicals that they also require in order to divide and produce new cells. So we're going to focus on temperature first, and we're going to be looking at a lot of these bell-shaped curves. So it's really important to understand what's going on with these graphs. So we've got the temperature on the bottom here. And on our y-axis, we've got the growth rate. So that's actually telling us about the number of microorganism cells, so whatever we're looking at. Okay, so as you can see, if you go up your y-axis, you're going to increase the number of cells. Okay, so each species of microorganism has a minimum growth temperature. And what this is this is just the minimum temperature at which they'll still divide and produce new cells. Okay, and if you go below that minimum growth temperature, they stop dividing. Okay, but if it's getting too cold, that oftentimes does not kill them. They just go dormant. So think about the food in your freezer. So if you pull out some frozen raw chicken and you thaw that to room temperature, and if you eat that, it's going to make you sick, right? Because by having that raw chicken in the freezer, freezing it did not kill off the bacteria that are all over that raw chicken. Okay, so freezing usually does not kill the microorganisms. Okay, so kind of keep that in mind. So that is key with food safety. Okay, and then up here at the top of our graph, we have our optimum growth temperature. And the optimum growth temperature is the temperature where they grow and divide the best. So they're going to be dividing like crazy and producing the maximum number of cells. So each species will have their optimum growth temperature where they're going to divide the best and produce the most number of cells. Okay, and then we get to our maximum growth temperature. And the maximum growth temperature is the maximum temperature that they'll still be dividing at. And if you go above that maximum growth temperature, they're no longer dividing. And that's because it's gotten too hot and proteins start to denature and you're going to kill off the microorganism. So that's why we cook our food. Because if you cook that raw chicken, that will kill off the bacteria, it denatures their proteins and kills off those bacterial cells. And so then it's safe to eat. Okay. All right, so we've got a couple of terms here that are important to know. And what we're looking at is the optimum growth temperature. So we've got our little bell-shaped graph here. Oops. It's not wanting to work here. There we go. So we're just looking at this optimum growth temperature here where they divide the best. Okay, so that's what we're looking at with these terms. All right, so we can classify our microorganisms into three main groups based on their optimum growth temperature. So some microorganisms grow best at colder temperatures. So if they have an optimum growth temperature that's on the colder side, we're going to put the prefix psychro in front. So psychro is just referring to cold. Okay, so they're not psycho. You might think they are because they like cold temperatures, but it's psychro with an R. Okay, so depending on their optimum growth temperature, which you do not have to memorize these numbers, so you don't have to memorize those, but just remember that if you have a psychrophile or a psychotroph, their optimum growth temperature is in the colder range. Okay, so a great example of this, if you've been hiking in the summer in Utah's mountains, you might have seen pink snow. So what gives the snow this pink color is there's actually algae that is growing in the snow. It's actually a green algae, and it has a carotenoid, a photosynthetic pigment that is actually using as a sunscreen, and it happens to be pink. And so that's what gives the snow that pink color, because of the algae that's growing in that top layer of the snow in the summer. And if you pick up that snow and smell it, it does smell like watermelon. I wouldn't eat it because I have heard that it can give you some diarrhea, but that's it. So otherwise it's not going to make you super sick or anything. So, but the diarrhea would not be fun. So that's an example of a psychrophile or a psychotroph. Okay, the next group we have are the mesophiles. Meso means middle because they kind of have a middle temperature range. And if we think about the human body temperature in degrees Celsius, so we're all familiar with degrees Fahrenheit, but if you work in a hospital, you probably know that the human body temperature is actually 37 degrees Celsius. So a lot of our pathogens, the microorganisms that make us sick, are actually mesophiles. And their optimum growth temperature, where they divide the best at and make the most new cells, would be actually at our body temperature. Great. Okay, so I remember that most pathogens are going to be mesophiles. Okay, so that would be important to remember. Okay, and then we have our thermophiles and hyperthermophiles. And therm means heat. And so you can see that they like to grow and divide the best at very high temperatures. So like the microorganisms living in hot springs, like up in Yellowstone or in deep sea vents, very high temperatures, those would be thermophiles and hyperthermophiles. Okay, and then here's just the names of these three groups that we talked about with their temperatures. And you can see the top here with the optimum growth temperature for the mesophiles. And you can see 37 degrees Celsius, the human body temperature, perfect for these mesophiles to be dividing like crazy. And you can see why they are having a party in our body and making us sick. Okay, so this leads us to food preservation and why we have refrigeration, freezing, and cooking our food is because of these mesophiles that make us sick. So I think it's easier to look on the degree Fahrenheit temperature scale on the left, just because we're all used to that. So if you leave your food out at room temperature, that allows these mesophiles, these human pathogens that could be on or in our food, to divide and multiply, and then if we eat that food, that can make us pretty sick. But if we cook our food and bring it up to really high temperatures, remember that that's going to get beyond the maximum growth temperature for our mesophile, and if we go beyond that, remember that's going to denature the proteins in those mesophiles, and that will kill them. And so that's why we cook our food. And then if we refrigerate our food, many of the mesophiles are going to be beyond their minimum growth temperature, and so they just go dormant and they're really not going to be dividing, and so they won't multiply in the refrigerator, and so that's going to keep our food safe for much longer than if we left it at room temperature. And then if we freeze our food, they're really not going to be able to divide at all. But obviously if we take the food out, leave it at room temperature, let it thaw, then the bacteria get back into closer to their optimum growth temperature, and then they start dividing, and then if we eat that raw chicken or raw beef or whatever, then we could get sick from that. Okay, another physical requirement for microorganisms to grow would be pH. And what does pH measure? Why is there a big H in the word pH? So if you look at the equation for measuring pH, it's the negative log of the hydrogen ion concentration. And so you can see that pH is measuring the hydrogen ion concentration. So that would be important to remember. So that's what you're measuring in pH. Okay, remember pH, the scale goes from 0 down to 14 or up to 14, and 7 in the middle is a neutral pH. And so you have an equal number of hydrogen and hydroxide ions. But if you go pH less than 7, that would be acidic because you have more hydrogen ions. And if you have a pH number greater than 7, then that would be basic because you have less hydrogen ions. So kind of be familiar with that scale. And pH is important because if you're out of the normal pH range for a particular protein, think about what happens to the protein. Remember that they will denature. So not only will high temperatures denature proteins, but also if they're out of their normal pH range, that also makes them denature and unfold. They lose their shape and then they can't do their jobs anymore. And then that could kill the microorganism as well. Okay, and of course we've got names for where bacteria prefer to live as far as on the pH range. And most bacteria are going to be what we call neutrophiles. So they like to grow more around a neutral pH, somewhere around 7. You don't have to memorize any of these numbers, just know what the terms mean. And then if the microorganism likes to live in a more acidic environment, they're an acidophile. So think about Helicobacter pylori that likes to live in the stomach. That would be an acidophile. Or if you have microorganisms that like to live more at basic pHs, they would be alkalophiles. So like the ocean water has a pH a little over 8, and so all of those microorganisms living in the ocean, they would be alkalophiles. Okay, and then we get the same bell-shaped curve for pH. And so if you have something that is an acidophile, you can see that here's our optimum pH growth. So here's where they would grow the best at, produce the most cells at this particular pH. But if the pH gets higher than that or lower than that minimum pH range, then the proteins will denature, and then that will kill the microorganism.